Okay, we're back at Stanford Systems. Take it out. Take a look at this. This is amazing stuff, isn't it? I really got to clean up that table, don't I? Okay, this is where we're at on the UAV style drone. You'll notice it's got 8 motors. It's a quadcopter, but I've doubled up the motors on each arm. Let's take a look at some of the detail work. I've decided to mount the ESCs vertically, like this. We have the geodesic joints resined up. Basically, they're just dowel hangers with acetone dissolved ABS plastic that I basically just solvent welded it together. It's held in place with a small machine screw internally, and as you can see, it's actually pretty good. We further augment it underneath with these little wire ties, they call them, and what we do is we extend it from here all the way up to here. There's a piece of wire that goes that we've already checked that the props clear it. Okay, we're basically using various geometric, like geometry techniques with which to keep the whole structure firm. This is a servo gear. Interestingly enough, you can use one of these things to excite one of these 3-phase drone motors through an ESC. Okay. These are the battery holders. I basically drilled them out and made them so that they could hold, or rather conduct, more amps. Okay. Let's see if we can demonstrate something here. I'm going to sit down, and what we're doing is we're powering off of a 2 amp 5 volt tablet brick. Okay, you might have seen that from previous videos. And what we're doing is we're feeding the power in real low tech wise here. Basically it taps into the power buses, into the powertrain. It's just some extension cord wire. We've wired everything in extension cord to keep it cool. So let's do the demonstration. I plug in my tablet brick like this. Let's see where we have it hooked up. I thought I had everything prepped for this, but this servo gear should have lit up as soon as I. Oh, that's why. I pulled the power off of it accidentally. Let me fix this real quick. Okay, we have the power going through it now. You can see the light on the servo gear is on. I believe we have it hooked up to this pod here. Let's just make sure that the rotors involved will clear all of the junk on my table. Okay, so what we do is we rotate the gear. There we go. So the servo gear's pulse width modulation signal is going through the signal wires to the electronic speed control, which is wired up to the top motor on the arm. Okay, really simple. Interestingly enough, we're using the BECs, they're called BECs, B-E-Cs, to power the servo gear. You'll notice it's doing something really magical here. You see how it's not plugged in? It's because the BEC comes through the pulse width modulation wiring. Okay, the power that's powering this little thing here is actually coming from the electronic speed control. It's not magic. So let me quickly hook up the other corresponding counter rotating motor. Okay, all I did was quickly add the other pulse width modulation signal wire into my servo gear. Okay, now watch this. Okay, it's still not turning. What we're trying to do is we're trying to get the lower prop here turning. Okay, let me pull the top one out. It is kind of true what they say about these systems are pretty complicated. Okay. Here's the lower motor. Okay, let's see if we can get them both going on at the same time. Here we go. There we go. How's that? You'll notice we don't have the other motors hooked up. I'm currently in process of wiring this one. Basically what we do is we hot glue these little pieces of foam board to align the electronic speed control boards, okay, vertically, so that when it flexes it doesn't break the boards in the electronic speed controls. Then we go over it with electrician's tape like this, and it's actually quite a handsome little setup. So this is what one of your UAV style drone projects might look like. Okay. Talking about other parts, of course we got my $2 dollar store scientific calculator and my volt ohm meter. Okay, now look at this. This is what we're planning for some intermediate tests. Right now I have two IMUs on it, and that chip up there is a PIC 16F88. what we're going to do is we're going to take our little Beagle board and one of these bad boys right here, and it's a Beagle board black wireless, okay, and we're going to put it underneath this board, and then we're going to connect it with wires like this, okay. What we'll probably do is power off of the facts, and that way we get voltage regulation to 5 volts, which is basically what these components eat. If they do take 3.3, we can take it off of the voltage regulation rail on the Beagle board, which is right about here, in case we need 3.3 volt. But we do have to work out how many amps it takes, because these boards can't handle a lot of amps through them. So we basically do this. The Beagle board will be mounted here in between the baseboard of the drone and this little board here. So that's the end of our presentation.